Okay, so the last chapter of the syllabus, chapter 12, linear regression and correlation. So starting from chapter 8, we have been discussing methods of inference, right? So how do we make conclusions, predictions about the population mean and population proportion. In chapter 8, we talked about how do we build an interval estimate, a confidence interval, to estimate population mean or to estimate population proportion. And in chapter 9 and chapter 10, we talked about how do we validate a hypothetical statement about the population mean and how do we validate a hypothetical statement about the population proportion. And chapter 12, we are going to deviate from that idea, and we are going to study about measuring relationships between variables. How do we numerically capture the association between two variables? Is there any association exist between variables or not? So we are going to talk only about two variables, but this idea can be generalized into as many variables as you have. So we're going to talk about two main methods, linear regression, and the other method is called correlation, coefficient of correlation. Okay, so when you think about two variables and when you think about what is the idea of association between variables, relationship between variables, so in practice, sometimes by common sense, by general knowledge, you already have some sort of idea about the relationship. If I give you examples, just think about mileage of a car, and its selling price. So we have two variables here. One is the mileage of the car, it varies, and the other one is the price, right? The selling price. Okay, so when you think about the association between two variables, so what happens? You can just pick a direction. What happens when the mileage increases? What happened to the price when mileage increases? Just can ask that question to figure out the relationship. What would be the price? What would happen to the price when mileage goes up? So in practice, by general knowledge, you would say it goes down, right? Price goes down, selling price drops. So you can see when mileage increases, price decreases. So you have a negative association in between these two variables. So this is by general knowledge, right? By seeing. If you look into prices of the cars for a certain brand, you would definitely see as the mileage goes up, the selling price tend to go down. So by general knowledge, without applying anything, you know just by general knowledge that there is a negative association, right? And then another example, think about the study time, your study time for preparing for your exam. Study time and your exam score. What do you think? So by your common sense, you know if you study a little more, you could land on a better grade, right? So as you increase the study time, so any rational person would understand that if you study a bit more, your score is going to get better, goes up, right? So this is a positive association. So when one variable increases, the other one, with respect to that, the other one would also increase. Positive association. Okay, and then so I can name few more. Think about education level of education, and the income or salary. Okay, so think about what is the relationship. And so you can see in all these, by using your general knowledge, your common sense, you would easily identify what kind of association that we have between these two variables, right? But these are just without any evidence, right? These are not educated conclusions. So in regression and correlation, we are going to provide solid proof. We are going to prove that when you increase the study time, the exam score actually goes up. So numerically capturing these relationships between variables. That is the purpose of studying about regression and correlation, because in practice, when you work in a factory and then you have to provide your manager some reports, you cannot just say, okay, by general knowledge, by common sense, if we make this new change, that will improve the production. You can't just say that. You have to provide evidence, right? So how do we numerically provide those evidence? It is through these methods, linear regression and correlation. Okay, right. So next we'll talk about the idea of independent variable and dependent variable. So when you talk about dependent variable, sorry about that, and dependent variables. So when you think about two variables, so always we change the numbers of one variable to see how that would impact on the other variable. That's how it works. So in all these cases, you think about what happens to the price when you change the mileage, right? When you increase the mileage, what would happen to the price? So the value that you change in order to see the impact on the other one, that's the independent variable. So the value that you usually change is the independent variable, and you want to see what would happen to the other variable. So that's the dependent variable. So in this first example, mileage is your independent variable, and the price is the dependent variable. And here you want to know, when you change the study time, what would happen to the exam scores? You're changing the study time, independent variable. You want to know what would happen to the exam score, it's dependent variable. And here, level of education and salary. So you want to know, as you increase or decrease the level of education, what would be the impact on salary? So this is your independent variable, and the salary would be the dependent variable. So independent variable often refer as the x variable, x-axis, and the dependent variable is referred as the y variable. Okay, so we need this basic information, basic knowledge when we actually apply regression and correlation. Okay, right. So we do have actually 3 methods to numerically capture the association between variables. So one method is the simple plot, XY plot. We call it a scatter diagrams. So scatter diagrams would be the starting point of any regression analysis, because you get to see the pattern when you plot it X versus Y, right? But scatter diagrams are not the best way to provide solid proof about the association, because reading charts can vary from one person to another. We identify patterns different ways, right? So my conclusion based on looking at a scatter diagram would not be the same as your conclusion. Okay, but always as a beginning starting point, people always use scatter diagrams. So scatter diagram is very simple X versus Y plot. So whichever your X variable and whichever your Y variable. So you would have to have a table with X variables and then the corresponding Y reading. Okay, and then each data point, each pair will be denoted as a dot, right? So basically you have points scattered on your diagram. So you just look into the pattern. So overall this looks like an increasing pattern to me. So overall it is going up, right? So I can say the overall pattern would look like an upward trend. And if you have, so for that example, mileage and then the selling price, the plot might look something like this. Overall it's going downward trend in between mileage and selling price. So that's very simple and neat idea. But like I said, the point of view, based on people's point of view, by looking at the patterns, the conclusions may vary. So in this chapter, we are only going to focus on linear associations. We're not going to talk about any quadratic associations, any seasonal patterns. So if you see something like this in a scatter diagram, this is a seasonal pattern. It goes up and down, right? And you can even have non-linear patterns. And you can have something like this. So data are just randomly scattered. No pattern can be identified. So we can say no association between the variables. Or else you can have something like this, exponentially increasing patterns. So different kinds of associations, but we are only interested in this chapter, we are only interested in identifying linear. Linear means straight line. So your data gathered around a straight line. That's the idea of linear association. Okay, so we will be discussing how do we identify linear association between X and Y using regression and correlation. Okay, so method number 2 is linear regression. So linear regression means you are just plotting a straight line using your data set, your XY data set. You are going to figure out what would be the best straight line to describe my data set. So you have your scatter diagram, X versus Y. So these points, these are your data, the actual observations you observed. Okay, so we are going to figure out what would be the best straight line that could describe my data set. So when you think about best straight line, when you think about straight lines, there can be many different straight lines passing through this data set, right? So which one is the best? So that best one, we do have a method of selecting the best straight line. That method is called least square method. So I'm not going into details about the method, but applying the least square method, we figure out, is it the red one, is it the blue one, is it the green one? So we can figure it out. And for instance, let's say that it's the red one. So if the red colored line is the best representation of your data set, we call it, okay, this is the regression line. So this is the regression line of this data set. This is the best straight line that I can use to represent my data set or to identify the linear pattern in my data. Okay, and it's just nothing but a straight line, right? So this regression line can be expressed as y equals to a plus bx. So it's just the equation of a straight line. So in some textbooks uses this y equals a plus bx, some uses y equals I think it's c plus mx. Yeah, so different notations. I think our textbook uses y equals a plus bx. So this is not statistics, this is math, right? Geometry. So the connection, well, basically this describes the relationship between y variable to x variable. What's the linear relationship between y to x? And simple a and b are constants. Simple a and b does not change for the fixed line. So a is, just gonna get rid of this for now. So simple a stands for y-intercept and b stands for the slope of the straight line. Okay, so whichever value comes attached to the variable x, that is the slope, and whichever comes as a constant, that is the y-intercept. So if I draw again, here, so you have x versus y and your actual data, and then let's say this is the straight line, this is the regression line. And to make it stand out from all the other straight lines, because like I said, you can have many different straight lines passing through this data set, right? The best one is the regression line, and we, in order to make it stand out, we use y prime, not just y equals, just y prime equals a plus b x. So a and b, y-intercept and the slope, those will be numerical values when it comes to a actual question. Okay, so for example, it could be, so I'm just making this up. For example, your regression line could come up as y prime equals to 2 plus 3x. So just two numerical values. So these two will be determined by the least square method I mentioned before, and these two will be determined actually by your data. Your data is going to tell us what is going to be simple A and what is going to be simple B, and the way we figure it out using data is the least square method. So because of that, sometimes people refer to this idea as least square regression analysis. Okay, right. And once you figure out the regression equation, you can actually use the slope B to talk about whether the association is positive or negative, because if you have an equation like y prime equals to 2 plus 3x, again, for example, if you just think this is your regression line, 3, so this is positive, right? So positive slope. So positive slope means the line is moving upwards. Okay, so that means when you increase the x variable by 1 unit, y would it be increased by, as a result, the y variable will be increased by 3 units. That's the idea of the slope. Again, the idea of slope means, according to this example, when you increase your x variable by 1 unit, your y variable will go up by 3 units. Okay, and then, for example, again, if you have your a regression line turns out to be 5 minus 2x. Okay, so you applied regression line using your data, and then this is the outcome. So that means the negative slope. So now the slope is negative, minus 2, right? So the idea is it's going downwards now. So the idea is when you increase your x variable by 1 unit, your y variable would go down. It decreases by 2 units. That is the idea of slope. Again, when you increase the x variable by 1 unit, your y variable goes down by 2 units. So a negative association. So by looking at the regression equation, you can easily identify the association between x and y. Okay, that's the idea of regression analysis. And then the third method is called correlation analysis, or we call it correlation coefficient. So correlation coefficient, again, you use your data set xy, you obtain data, you change x variable, and then you observe y variable, and then using this you get this number. This is just a number, so a value called correlation coefficient, and we denote it by simple r. And by looking at it, by just looking at the number and the sign of this number, we make our conclusion about the association. So R is more powerful than the regression analysis, because R is going to talk about two sides of the association. One, it's going to talk about the strength of the association, and the other one is going to talk about the direction of the association. So direction is very simple. If R is positive, positive association. Positive association between x and y. And if R is negative, well, negative association between x and y. That's very simple. And the strength is based on where the value is. So basically you drop the sign, you forget about whether it's positive or negative, you just focus on the magnitude. So this R value can vary between -1 and +1. Okay, once again, R can vary between -1 and +1. So if it is closer to 0 from any direction, negative direction or positive direction, we say the association is weak. There exists an association, but it's a very weak association. And if R is closer to +1 or -1, we say strong association. Okay, so if you think of some examples, if your data set gives you a value R equals to 0.98, so this means plus means positive, R is positive and it's closer to 1, right? So positive, you can say very strong linear association. And then if R is, let's say, -0.78, okay, so this is negative and closer to -1. So negative, very strong association, linear association between x and y. And if R is, let's say, -0.41, so still the association is negative. So if I just roughly sketch the underneath scatter diagram for this picture, for this data set, your scatter diagram would be something like this. So moving upwards, and they are closely gathered around a straight line. And for this one, it's moving downwards because it's negative, and still it's closely gathered around a straight line. And here for R equals to -0.41, so this is closer to 0. It's more closer to 0 than being closer to 1, right? So it's weak. So negative, weak linear association. So that means, if I think about the scatter plot, weak linear association means, here's your straight line. So it's going downwards, but it's not really closely gathered around your straight line. It has more more spread around it, but overall it seems like it's moving downwards, but it's not a very strong linear association. So if you happen to have R equals to +1, this is the best. So this is a perfect positive association, positive linear association. So that means increasing, and all your points, all your data are on the straight line. All right, and similarly, if you think about R equals to -1, perfect negative linear association. That means all your points are on the straight line and it's moving downwards. Okay, so that is very simple. You look at the sign, you look at the magnitude, whether it's closer to 0 or whether it's closer to 1. Based on that, you talk about the direction of the association and the strength of the association. So that's correlation coefficient. And when I'm going through Megastat, I'll show you in the output you would also get another value called R square. So this is simply correlation into correlation, R into R. Okay, so this value is called a coefficient of determination. So coefficient of determination is going to decide. So I told you that linear regression, it's y equals to a plus bx, right? Y prime equals to. So we are going to talk about what is the association of your x variable. What's your association? What's the association of your x variable to y? So when you change your x variable, what would happen to your y variable? So basically we think that the only factor which changes your y variable is your x variable. The only factor which drops the selling price of your car is the mileage. But that may not be the only factor, right? By practice, you know mileage is not the only factor. If the car has gone through any accidents, any major repairs, there are so many other factors. So your x variable, the mileage, may not be the only factor deciding the selling price of your car. Okay, so the coefficient of determination is going to help us figure out what proportion, what percentage of the variability in your y variable would be described by this x variable. So mileage, by what percent the mileage would be responsible of the variation in selling price. So that's the goal of coefficient of determination. So if I give you some examples, if I have r square equals to, let's say, 0.98, so that means 98% of the variation in y variable is due to x variable. So there's only 2% of the variation in y is due to some other factor. So that means in this particular example, your x variable, whichever it is the key factor which decides the change in your y variable. And if you happen to have something like r square equals to let's say 31, so this means 31% of the variation in y variable is due to x variable. So according to this example, okay, x variable is responsible of the changes in your y variable, correct, but it is not the key factor. Your x variable only is responsible of 31% of the variation in your y variable. So this is a good example of the mileage versus selling price. So your selling price only responsible of 31% of the changes in your sorry, my bad, let me take that back. So your mileage of the car. Mileage of the car is only responsible 31% of the variation in your selling price. So there are other factors. So 31% means out of 100%, the rest is the rest of the changes. The rest of the percentage change in the selling price is due to some other factors we don't know. So coefficient of determination is really good when you decide whether this association should be linear or should we consider multiple regression or non-linear analysis, because for this particular example you can definitely see by building a relationship A plus bx, this is not enough. This is not going to actually provide us the actual picture, right? There's more than mileage. Mileage is just one factor. What else? Is this the only variable or not? So deciding that, so you may have another variable z, a plus bx plus c z. So there might be another deciding factor, right? So deciding whether to go with the linear analysis or deciding whether we need to go further and look into multiple regression or nonlinear analysis is the goal of looking at this number, coefficient of determination. Okay, so once again, let's scan through 3 methods. First one, easy, just the scatter diagram. You just look into x versus y of your data set, look at the data, look at the pattern, try to identify or try to get basic understanding of the association. That's scatter diagram. And then that's not enough, because patterns, you never know, people can identify them different ways. So we need solid, much more something solid than that. So linear regression is the next thing to do. So in linear regression, we plot a straight line passes through the data using a method called least square method. So by using the least square method, we find the best straight line represent our data set. And that best line out of many straight lines which can actually go through this data set, we call it the regression line. And that best straight line, we name it y prime equals to a plus bx. And I forgot to mention that another use of this straight line is that you can predict values. So whenever you want to predict a y value for a given x, you can use this straight line. So if you have an x value over here and you are wondering what would be the y value, so I don't know, I'm just going to come up with the number. So when x is 3, what would be the corresponding y? So you can use this regression line, go straight up, and then you can read the predicted y value. So in addition to figuring out the association between x and y, we can use regression line to make predictions. So if the slope is positive, we know the association is positive. And if the slope is negative, the association is negative. And then same idea, correlation coefficient. We try to measure the association between x and y under 2 categories. What's the strength of this association? What's the direction? So for a value which is positive, the association is positive. That means when you increase the x value, y value goes up. and if r is closer to 1 in magnitude, it's a strong, very strong association, and if it's closer to 0, it's a weak, very weak association. And then the last topic, correlation coefficient, simply the square of the coefficient of determination is simply the square of correlation. And the goal of coefficient of determination is to figure out is x variable is the only variable which changes y value, or are there any other factors that we have to take into consideration? Or in simple words, is linear regression enough? Do I need to look into multiple regression? Do I need to look into a non-linear analysis? Okay, right, so that's the lesson part, and then let's use all these, and we're going to get all these numbers through Megastat. So next video I'm going to show you how to do that.